Recording is rolling. I'm just recording part of this class because I'm picking a few problems from chapter 6, just as review of projectiles. So pick a few per class so you guys get some extra examples. Let's say number 55, swimming. You took a running leap off a high diving platform. You were running at this speed, and though you hit the water this many seconds later, how high was the platform? And how far from the edge of the platform did you hit the water? Ignore air resistance, which of course is one of our running assumptions anyway. So number 55, swimming. What I'll probably do is start with a picture and label everything we know, and then figure out everything from there. So high diving platform. That sounds kind of like a cliff, doesn't it? Maybe I could use a cliff or something similarly shaped. This idea. So you're diving off right here. What do we know? Oh, we know how fast you were running. So I'll call it V sub x. Now that's the running speed, but that'll be the horizontal speed all throughout this trajectory, right? You'll be going splash, something like that. I'm going to make up my own number. I'm going to call this 5 meters per second. A little bit different from the textbook, but you get an extra example. There you go. And it says you hit the water after some time. So the time from here to here, I'll make up my own number again. I'll call it 2 seconds exactly, 2 seconds. Okay. And the question was, what's the height of the platform? So I'll call it H. And also, how far from the edge of the platform did you hit the water? That's to say, from this point to the splash point. If I call this X, what's X? So what is H and what is X? That's the two questions. Okay. All right. Well, what should I start with? Actually, you know what? You could, looking at the numbers now, you could actually start with either question. So let's do the order that they asked them. So they asked for the height of the platform first. So wouldn't that be, how can you get height? You can tell me. Do you remember a Paul Hewitt story that involved a mine shaft? Yeah, right? If a rock had been falling for 5 seconds, it's about 125 meters deep. Isn't that sort of what we got going on here? If you just focus on the vertical part. Hey, if someone's been falling for some number of seconds, and you want to know how far it's fallen, isn't that the mine shaft story? Huh. And what was the formula for that? 1/2 AT squared. Yep, 1/2 AT squared. Where, of course, we're talking about like a gravity field for the acceleration, so it's a special kind of acceleration. But it is 1/2 AT squared. Let's do 10 meters per second squared for 2 seconds. 2 squared is 4, times 10 is 40 over 2. Look at it, it's about 20 meters. There you go. Now that's the height. The other question was, how far from the base do you land? So, well, if you know your running speed and you know the time you were in free fall for, isn't it just this times this? Right? Remember, horizontally, there's only one equation in projectile motion because there's no acceleration horizontally. It's just x equals vt, where we're talking about, of course, v in the horizontal direction. So if you were running at 5 meters per second and you did that, and you were going through the air for 2 seconds, wouldn't you be going 10 meters away? There's your x value. There you go. So there's the height of the platform, 20 meters, and there's how far from the edge that you splash in the water, about 10 meters. Guys good? So I want to add on my own questions to this. I wonder how fast this guy's splashing in the water. I mean, it's got to be faster than his running speed, right? Because once he leaves the platform, he only speeds up after that. Do you guys think we could figure out how fast this guy is splashing in the water? Call it V splash. Right? Think we could figure that out? And the way we could figure that out is, well, you'd have to know what is his velocity horizontally, what is his velocity vertically at the point that he's splashing in the water. And you know what? We already know the horizontal value because It's already written on the page. It's what is the horizontal value of splash? Just the horizontal component. What is that equal to? 5 meters per second. There you go. So v sub x is always 5 meters per second. So you should ignore air drag because v is going across all the way down. Now vertically, what is v final in the y direction? What is that going to be? Does anybody happen to know? Oh, okay, so how could you get it? I'm thinking, well, we got some options. If you want to know, it could be either this or this, but probably this one's easier. He's been falling for 2 seconds. And hey, what is his initial velocity in the vertical direction leaving the platform? 0, yeah, because leaving the platform is not moving up or down. Okay, so if you just look at the vertical, treat these as vertical components, right? Accelerates vertically, right? Vertical. This number would be 0 at the edge of the platform, right? It's not moving up or down. Let's do that. So final velocity in the y direction equals initial velocity in the y direction plus gt. Right? Down is positive, so starts at 0, picks up at 10 meters per second per passing second. Does that for 2 seconds. That was a given value, 2 seconds. So I take this equation, be really fast. Okay. Wouldn't that just give you 20 meters per second? 20? Okay. Now, that's not the final answer, although it's probably not too far off from it. That's this component, 20 meters per second. Okay. Anytime you're falling for 2 seconds, starting from rest, you will have picked up to 20 meters per second vertically. Okay. But don't forget also that he has a horizontal component, which is 5 meters per second. So wouldn't his total splash speed be like a combination of the two? Okay. But you don't just add them. You don't say 25. You have to use what method? Pythagorean theorem. Okay. Notice that this triangle, this is a right triangle. You see a right triangle here, geometrically? Notice that this arrow does not go back to the edge of the platform. Notice how it's like tangent to this dashed parabola right here. See, it's like flush to it, right at the splash point. So we're going to do Pythagorean theorem. V splash equals, so this is Pythagorean theorem, square root of, vx squared plus v final and y squared. So there's a general expression for Pythagorean theorem. Pop in those numbers. So it'll be 5 meters per second, 20 meters per second. Those are the two values. Square them, add them together, take the square root. Square root of 5 squared plus 20 squared. Okay. Now before I hit enter, I'm going to make a guess. I'm going to guess that this is between 20 and 21 meters per second. I'm going to say it's a little bit faster than 20. I don't know, but we're going to find out. Maybe 21. That's my guess. 21 meters per second. Okay. Let's see. How close is that? Ooh, 20.6. Hey. Okay. So it's just a little bit more than the vertical speed. So 20.6 meters per second. Let's do another one of these. No, let's do another diver. So number 59. Divers in Acapulco dive from a cliff that is 61 meters high. Woo! That doesn't sound safe. If the rocks below the cliff extend outward for 23 meters, oh boy. What is the minimum horizontal velocity a diver must have to clear the rocks? Okay, so if you were ever down, this is in Mexico, right? If you're ever down there doing some cliff diving, remember if you just step off and fall all the way down, you're going to crash into some rocks. You better have a running start. How fast do you have to go? Well, we've got to find out. So number 59. So here, you're about to dive off this cliff. That is, say, h equals 61 meters. I'm going to change the rocks just a little bit. Let's say they go out to like 25 meters. A little bit different from the text. So x equals 25 meters. Right. And you want to clear that. So you have to be running fast enough. I'll say v sub x. Let's see, we just barely missed the rocks. You just barely missed the rocks. It might look like that. Okay. So how fast do you have to be running for that to happen? Okay. So what I'm thinking is that at some point, there we go. At some point, we're probably going to have to use x equals vt, just horizontal, because I know how far horizontally you have to go. I'm trying to figure out how fast horizontally you have to run. If only I knew the time that this guy was falling for. But hey, the time, that's going to be constrained by the height of the cliff. Okay? So I need to start with the vertical stuff to figure out how much time does it take to fall that height. And then later on, I'll figure out how fast you have to run. So horizontal. So I'll start with vertical stuff. Start with vertical. Hey, wouldn't this just be the h equals 1/2 gt squared, the old college equation? But we're going to rearrange and solve for time this time. Okay. So I know falling 61 meters. Notice I left off the v naught t part because v naught in the y direction is 0 at the start. If you're just looking vertical, and you're only running off the edge horizontally. Okay. That's why v naught y is 0. So you're going to fall 61 meters, starting from rest vertically. You're picking up at 10 meters per second squared. And how much time is it going to take to fall 61 meters? Remember, if you drop something at the same time, fall side by side. So cross multiply 2 divided by 10. What is 61 meters times 2 over 10? I'm looking at 12.2, and then the units also follow, so that would be square seconds. That's equal to t squared. Okay, square root both sides. Looks like you'll be falling for about 3.5 seconds. Yeehaw! I would not want to be falling. That would be a very long 3.5 seconds to be falling. So now let's switch over and look at horizontal. Now this is where I was trying to start, but I didn't have enough information, but now we do, because now we know the fall time. This is what I'd really like to do. X equals vt. Or maybe you could start with this, because then what you're trying to solve for is just distance over time. Right? Horizontally. It's all horizontal displacement over time. So if this guy goes 25 meters in 3.5 seconds, then what does that divide out to? That looks like you'd have to be running this many meters per second. I want to say that's close to 20 miles an hour or something like that, which is probably about as fast as someone can run. Yeah, okay. You'd have to full charge the edge of that cliff. Yeah, because if you didn't, you will die. Right, let's do one more. How about 58? At sea rescue. An airplane traveling 1,001 meters above the ocean, going at this many kilometers per hour. Okay, well, we'll have to do a conversion. Yes, kilometers per hour. Don't we have to convert to meters per second first before we can do anything for that? Okay, so we'll actually get there. He's going to drop a box of supplies to shipwreck victims below. How many seconds before the plane is directly overhead should the box be dropped? And what is the horizontal distance between the victims and the drop box? So gonna have throw a little island here, little island trees. Right. Got some people eating coconuts off that tree, but they're running out of coconuts real fast. And got a plane up here that's moving at what I'm gonna call v sub x. That's really sorry guys, zoom out for you guys. Okay. So there's the island with the trees and the guys. Here's the plane moving some v sub x. It's gonna drop a box. It's going to, and this guy's going to catch it. Suppose you know the altitude of the plane. I'll call that h. How far in advance of the drop location do you have to actually drop the supplies? Because if you get right over top of them and drop them there, of course, the supplies are going to go way over, way into the forward. So you were given the height, the altitude of the plane. I'm going to make up my own number. I'm going to say this is like 500 meters. Different from your book, but we'll go with it. And let's say the plane is going at, let's say an even 100 kilometers per hour. Okay. I'll do the conversion with you guys. So you do have to convert to meters per second. Do you guys know that there are 1,000 meters in 1 kilometer? And do you guys know that there are 60 by 60 is equal to 3,600 seconds per hour? Okay, so kilometers cancels, hours cancels, we've got meters per second. Okay. Let's see the speed of the plane in meters per second. So 100 kilometers per hour is equivalent to 27.8 meters per second, which also, by the way, is really close to like about 62 miles per hour. So you cared about that. Okay. All right, so how far in advance? And what are the questions? Of what's the time and what's x? So we gotta solve for time. Now, the drop time, that actually has nothing to do with the horizontal motion. The drop time has everything to do with the altitude of the plane, because the plane's moving horizontally. So let's start with the college equation, 1/2 gt squared. We just basically did this a moment ago. 2h on g is t squared. Maybe I should have done this to start with, found a general expression. Notice I haven't plugged any numbers in. See, if I solved for this general expression first, then I wouldn't have had to redo that, because we could have just copy pasted that expression and then just popped in whatever numbers we want. That's one of the powers of this process. So I've got an altitude of 500 meters. I know it's falling at a rate of 10 meters per second squared. Rate is picking up speed. So how much time does it take to fall 500 meters? Huh? What's the square root of 2 by 500? 10. Okay. Oh, 10 seconds exactly. Wait, is that really true? Wow. Okay. So 10 seconds. You try it the other way. 1/2 g t squared. Okay, yep. I guess in 10 seconds, anything will fall 500 meters. How have I already taught this many years and not known that? Well, I know it now. There you go. So that's one of the answers. The other question was, how far in advance of the drop location? What is x? Well, if you know the speed of the plane, and you know the time of fall, all you have to do is put 2 and 2 together. I mean, this is all vertical information here. Here's all vertical. Let's switch over and look at horizontal information to get the other answer. Horizontal. That's to say, x is equal to v sub x times t. And we know v sub x because we just did the dimensional analysis and got 27.8 meters per second. And you know the time of fall because, we just found it right here. Pop that number in, 10 seconds to fall those 500 meters. So put 2 and 2 together, it looks like you want to drop that box 278 meters ahead of the target. So there you go. Now you know that x is equal to 278 meters. Guys good there? All right, so like I said, I'll post these to Google Classroom in addition to the other class recording, so you guys will have lots of extra review problems if you need them.